already heard of and probably already done problems with at some point in a math class, and that's the Pythagorean theorem. So can anybody tell me what the Pythagorean theorem says?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared is the then part of the Pythagorean theorem. The if tells us when we are allowed to do this. If it's a right triangle. So it's important that we consider that if part, because a lot of times when students learn the Pythagorean theorem, they just start plugging stuff into it no matter what kind of a triangle we're looking at. So the Pythagorean theorem only works in a right triangle. So the Pythagorean theorem says in a right triangle, or if you have a right triangle, then the square of the hypotenuse is equal to the sum of the squares of the legs. So when we have a right triangle, we can say a squared plus b squared equals c squared, where c is the hypotenuse, and it's important that c is always the hypotenuse. When Pythagoras thought about the Pythagorean theorem, that's why it's called Pythagorean, because it was Pythagoras that thought about this, he thought about it pictorially. He didn't think about it in terms of algebra and squaring things. He thought about actually drawing squares. So he said, if I have a right triangle, and I draw a square on one leg and a square on the other leg, I should be able to add up their areas and have it be the same as the square that I draw on the hypotenuse. So the square that's over on the left-hand side there, what's its area? 9. There's 9 little squares inside there. Side of 3, so 3 times 3 is 9. What about the bottom one? 16. So Pythagoras said that that upper square should have an area of 25, but inside of there we can't just, because we've got some whole squares, but then we've got a lot of them that are getting cut. But he said if we could arrange all those cut pieces together nicely, it should work out to be that there are 25 squares inside of there. So that's how he thought about this. So when we say that it's the way it's written on the notes, that it's the sum of the squares, he was actually thinking about squares, not like the little symbol like squaring a number. He was actually thinking about adding up squares. The Pythagorean theorem is interesting because it has been proven. Or be proofs, it will be solving problems, so we need some practice solving problems to make sure we know how to do these. So the first skill that we need to make sure that we have is being able to simplify square roots. To simplify squares. To simplify a square, if I have a square root of 5 squared, what will I get?
25.
I'll get a square root of 25, which is 5. Okay? A square and a square root cancel each other out to leave what was inside. So squaring the square root of 5 will give us 5. When we square a number that has more than one part to it, we must square all of the parts. So I square 7 and I get 49, and I square the square root of 2 and I get the square root of 4, or 2. Okay? Squares will cancel square roots. 49 times 2 then is 98. Okay? So when we're squaring a number that has more than one part to it, we must square all the parts. Square the 7 and get 49. Square the square root of 2 and get 2, and then multiply that together. Likewise with a fraction. When you square a fraction, you must square all the parts. So what will I get on top? 9. What will I get on bottom? Square root of 25, which is 5. So I square 3 and I get 9. Square the square root of 5 and I get 5. What do I get on top of the last one? N squared. What about on bottom? 3, because a square cancels a square root and just leaves what was inside. So we square the top and get n squared, square the bottom and just get 3. So we'll be squaring stuff a lot in our homework because a squared plus b squared equals c squared. We're going to do a whole lot of squaring. So being able to square numbers is going to be an important skill. In the first triangle, the upper left-hand triangle, which side of that triangle is the hypotenuse? 10. And in terms of A, B, and C, when we say a squared plus b squared equals c squared, c must be the hypotenuse. It doesn't so much matter what the a and the b are. They can swap around. It's not a big deal. So I'm just going to say a is x, b is 7. It doesn't really matter, but c has to be the hypotenuse. 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 Hypotenuse.
How do you know that that one's a hypotenuse?
It's across from the right angle.
Oh, well, if there's not a square there, how do you know?
There should have been a square there. This is the most common mistake that students make. The most common mistake that students make is setting up your wrong A, B, and C. A and B don't really matter, but C has to be the hypotenuse. A lot of students would take this problem and say 7 squared plus 10 squared and just square the stuff that you're given and put it together. You can't do that. When you set it up, you have to make sure that that hypotenuse is always alone. So then to work this out, what is 7 squared? 49. What is 10 squared? 100. Then what do I do to solve it?
Minus 49.
Subtract the 49. So x squared equals 51, but I want to know what x is. So take the square root. We'll undo a square, and I get x is the square root of 51. Square root should always be simplified when possible. What divides into 51? 3 times 17. 3 and 17 are both prime, so there's no other way to divide this up, and neither one of them is a perfect square, so that's it. That's as good as our answer gets, the square root of 51. But you should always simplify a square root when possible. For the top middle, which one of those is the hypotenuse? X. So x has to be c, which is the one that has to be by itself. So 4 squared plus 6 squared equals c squared. What's 4 squared? What's 6 squared? What do we get when we add them up? 52. That equals c squared. How do I get c alone? Take a square root. What divides into 52? 2 times 26. It's true, but neither one is perfect square, so it's not helpful. What else divides into 52?
4 and 13.
4 and 13, and that is helpful because 4 is a perfect square. What is the square root of 4? 2. And the square root of 13 is not pretty, so it stays what it is, and we get 2 squared root of 13 as our answer. We're going to go down to the bottom left-hand one. Which one of those is the hypotenuse? X or 7 squared root of 2? The 7 squared root of 2 is the hypotenuse. So that means when we set this up, we should have x squared plus x squared equals 7 squared root of 2 squared. What's x squared plus x squared? X to the 4th would be what we would get if we were multiplying them. If I'm adding them up, x squared plus x squared gives me 2x squared. Now remember, when we square a number that has more than one part, we must square all of the parts. So we have to square the 7 and get 49. Square the square root of 2 and get 2, or the square root of 4, which is 2. So that gives us 98.
Can you say that one more time?
Yep, when we square 7 squared root of 2, we square the 7 and get 49, square the square root of 2, and squaring cancels the square root, so it just leaves us with 2. Multiply that gives us 98. What do we do next to solve this problem?
Square root 98.
Not quite a square root yet. Divide by 2 first. Get the squared thing all alone, and then finish it with a square root, giving us 7. Bottom center. Which one of those is the hypotenuse? The 2x. That means the 2x has to be on the side by itself. So I'm going to say x squared plus 5 squared of 3 squared equals 2x all squared. I get x squared plus, when I square 5 square root of 3, I square the 5 and I get 25 times the square root of 3 squared is, that's a 3 in there. It's a 3. It's just bad handwriting and it keeps smudging worse the more I do it. There we go. 3. 75.
Don't you mean sneeze?
On the other side, again, when you're squaring something that has more than one part, you must square all the parts. So square the 2 and get 4. Square the x and get x squared. You must square all the parts. What do I do next in solving this problem? We're going to subtract the x squared and get all those x squareds together. So we've got x squareds on both sides. Let's get them all together. So that gives me 75 is 3x squared. Then divide by 3. That gives me 25 is x squared. So take a square root and I get 5. Kind of interesting that in the first two problems, which had nice numbers, 10, 7, 4, 6, we ended up really messy answers. But in these last two that really had kind of messy numbers in them, like square root of 2s and square root of 3, we got nice, clean answers. It's not always the case, but you can't tell really from the start of a problem whether it's going to turn out nicely or not. In this last picture, there's something missing. We were supposed to have a 9 written down here.
Where do you come up with that in the beginning equation that you square everything?
That's the Pythagorean theorem. A squared plus b squared is c squared. Oh. So we'll always be squaring it in all the problems. So you still need to square it. If it's already squared, you still need to square it because the formula says square it.
Wait, so if it's like square in the picture they give you?
You still square it again.
You put another square on it?
Yeah. I don't think you'll have any like that. But yes, you would put another square on it if it's already squared. Yeah. I don't think you'll have any like that though.
How do you know when to use this and what we did yesterday?
This is looking at a single right triangle and solving for a side when we already know two sides. Yesterday, we had multiple right triangles stacked inside of each other, and we wouldn't have known two sides of any one of those right triangles. In this last problem, I have a 6 and a 9, but they're not together in the same triangle. There's two triangles in there, and the 6 and the 9 are in different triangles. But what do all those little arrows in the picture mean? We've got parallel. So what kind of shape is this? It's a parallelogram. What do we know about parallelograms? Opposite sides are congruent. So that 6 carries over, the 9 carries over. So now in a triangle, I've got sides of 6, 9, and x. What side's the hypotenuse? The x. So we're going to go 6 squared plus 9 squared equals x squared. Hypotenuse always alone. 6 squared is? 9 squared is?
81.
36 plus 81 is? 117. Square root it. I can tell by looking at 117 that 3 divides into it. Our divisibility rule for 3 is if the numbers add up to something that divides by 3, then it divides by 3. So 1 plus 1 plus 7 is 9. 9 divides by 3, so it divides by 3. That's not exactly helpful, though, because 3 is not a perfect square. But if it divides by 3, maybe it divides by 9. Does it divide by 9?
Yeah.
9 times?
I don't have fingers.
11. 13.
And what's the square root of 9?
3.
And the square root of 13 is just going to stick around.
I just have one question. Where'd you get the 9 from?
The one at the bottom there. It has to be provided. I forgot to write it on the original time, so then I wrote it in new. Yeah.
So you just pick one of the triangles and then...
Just pick one of the triangles. Since x is in the middle, it's in both of them, so it doesn't matter which one you do. Your homework is from 8.2.